Okay everyone, so in the previous class we have seen two different problems from the auxiliary plane method of projections of the solids. So after talking about those two problems, some of among all of those problems have solved the problems which are inclined to horizontal plane alone, but whereas in this session I am going to talk about the auxiliary plane method of the projections of the solids when the given solid is actually inclined to the vertical plane. Okay, so I'm going to start the session. So I'm going to take the same example that I've taken earlier, not rectangular prism. I'm going to take this one. So pentagonal pyramid of 30 mm base edges and 70 mm long is lying on one of its triangular faces on VP this time. Okay, not on horizontal plane but on the vertical plane. So draw its projections when the top of the axis makes. Okay, no need to worry about this one. I'm going to erase all of this. And its axis, okay, axis won't be parallel, or just draw its projections by auxiliary plane method. So now I'm gonna take XY line. See here the values are around 3000. I don't want that much of magnitude. I'm gonna draw the initial XY line, making sure that around 250 mm. Yeah, that's fine. Now after that, once this problem is completed, then I'll go to the AutoCAD, because this is the last problem in the conventional part. So all the conventional topics were covered. Okay, only we were left with we will be left with this AutoCAD sessions. And this one. So here, so whatever the pentagonal pyramid that is there, by the way, this is a pyramid, which means it will be having an apex at the top, and at the bottom it will be having a plain lamina. Pentagonal pyramid of 30 mm base edges and 70 mm long is lying on one of its triangular faces. I think you guys might have know what does it actually means. So the pyramid that is actually saying is a pentagonal one. Okay, if I go to the shaded mode, I turn the grid off. Okay, in this mode I need the grid. What he's saying is, if there is something like this vertical plane is there, if there is a vertical plane like this, so let me extrude this one for a little bit. I just want to rotate this one about this point, keep the orthogonal mode on. Okay, so if it is so, if you assume this one as a vertical plane, here this particular solid that we have created should also be rotated and should also be positioned in such a way that it has 1 2 3 it has these triangular faces, right? So here one of these triangular faces has to rest on the vertical plane, so that is what we needed. So for that one, suppose if I was to keep this particular face here, I have to rotate this one through, you know, certain angle in the front view. Wait. Since the face is got selected, it was got, you know, curled in that way. Suppose if I take this one closer in such a way that, see here, I don't know whether you guys are able to see this. I'm going to try to rotate this one again. This time we need to turn this अरे यार won't listen, that's the problem. Okay, whatever. So if one of these, let me try this one more time. I don't know. Okay, this one is somewhat fine. And now if I take this one, no way, it is not listening to me at all. Okay, suppose if I move this one a little closer, so what happens? This particular triangular face is here, right? This particular triangular face will be on this vertical plane, right? So if it is so, we have to draw the projections. How does it looks from the front and how does it actually looks from the top? So that's the given job for us. I'm gonna try to draw the projections. I hope the problem is, you know, I hope that you guys have understand the problem. So if it is so, first we will assume that it is actually, its base is actually resting on the vertical plane, and then you know, we will we will rotate the entire plane in such a way that this particular pentagonal prism should be one of the triangular faces should be resting on the vertical plane. So for that, in the front view, we will get one of the triangular faces here have to be kept on the horizontal plane, so it will come like this. The vertical plane. Turn off the orthogonal mode. The angle is 162. Dimension is 30. 162. I did that several times, so that's the reason why I came to remember all these angles. Okay, again 30 at 162 degrees of angle. So let me draw an arc, keeping center, starting. Oh wait, I have to provide the radius. Center 30, and yeah, that's it. 30. Not where I want it to be. Now if I draw the projections, I'm gonna erase these two. I'm gonna give them different naming. And these two are very much closer, so that's the reason why. Okay. Now what's the height of the axis that was actually given? I'm going to trim these. I don't need any of these now because all I need is this point. I extended them. I thought it's like some prism or something. Axis that was okay. First we need to give the axis here. That should be the midpoint. Since the nodal one is actually got selected, here in this snapping points, it might get snapped to any other points. So that's the reason why I turn the orthogonal mode on, and then I'm extending all of this. I'll mark this as O. Axis should be 70. If there is a time for me, I will model the bicycle in the AutoCAD. It should not be A and A dash like this. It should be like A dash. Let's say A1. A1. E1 dash. E1 dash. Since this is going to be the front view, but still we have to give the same different namings. So I'm gonna treat it. We don't have to give namings here. C and E will lie here. C, E, and here D will be there. And I forgot to actually mention about the B here. Now at this particular location, O will be there. So if you observe in the previous concept that I've explained, actually in those cases I have taken, whenever the entire face has to be kept on this horizontal on this vertical on this horizontal plane. So I used to take a line which is along this line, right? So similarly I am going to do the same in the top view, because now whatever the line that is there, it is actually perpendicular to the, sorry, it is actually resting on the, let me delete this one for a moment. I'm going to call this one as x1, this one is y1. So the next step should be, we have to draw the projection lines perpendicular to the existing line. So first I'm going to draw these lines, and after that, I just want to make sure whether it is got, no, it has not snapped to the exact point that I want this thing to be. Since these lines have to be perpendicular, we can make them perpendicular by going into the parametric and click on perpendicular. This one as the first line and this one as second. Again do the same for the remaining ones also. That's it. Yeah, now what to do? So in the previous stages, since whatever the object that is there, in those situations it was actually it was actually resting on the horizontal plane. So that's why in the top view, so whatever the dimensions that are there in the top view, we used to take those dimensions and we used to keep them on the in the new, about the new x1 y1 line. So here we will going to take, I'm gonna hide all of them. Yeah, here we will going to take the distance of a1 dash, b1 dash, c1 dash, d1 dash, e1 dash and o1 dash from the existing line, because here we are rotating the plane about this one, which means about the, since it is actually resting on the, that face has to rest on the vertical plane. Now we need to take these dimensions. Okay, that's it. It is as simple as that. Let me trim this. Okay, so let me measure all the distances of the points from the xy line. This one is 21, 27.11, 17.84. D1 and O1 will be at the same distance, so we don't have to worry about them, which means we don't have to worry about the O. Okay, so let's take all the different dimensions and we're going to cut the arcs. We're going to make the arcs on these projection lines. So firstly I will come to the A1 dash is at a distance of 27.11, 27.11. If you want to get the arc in the reverse direction, hold the control while making the arc. and B is also on the same projection, but B is at a distance of 57.11. And A, B, C. C is at a distance of 66.38 and it is passing through this projection line. 66.38. Now after that D is at a distance of 42.11. And after that lastly E is at a distance of 17.84. Okay. Let me give the namings to these points also. We call this one as A dash, B dash, C is here, call this as C, D, E. Now the point D and O1 are at the same distance here. Sorry, this one is E. This one is D. So I'm going to cut the arc with a dimension of 42.11. I have to create the layer in which I have to add the ISO hidden lines. Text axis. What is this text axis? Good afternoon. Good afternoon all. I'm gonna mark this one with green color. Okay, so that's the solution to this given problem here. So how much? Only half an hour. It took only half an hour of time. So for the remaining 1 hour, I will talk about the AutoCAD alone. Okay, so here I'm going to model this one in the AutoCAD. I'll tell you why this one is somewhat complicated to draw. Okay, because whatever the situations that I'm going to face in this AutoCAD, that you people might face if you're trying to model this one using the AutoCAD. You know, anything like some complicated geometry is there, so you people might get confused. There is a reason why, specific reason why, that I've considered this one. I'll tell you why. Okay, let me open the AutoCAD and I'll go to the 3D. So first I'm going to try to draw a line. This 7, not what I needed. Let me zoom out a little bit. Okay, yeah, let me turn the orthogonal mode on. So what's the dimension here? 70 is the dimension. And 120 is another dimension. 70 again. In order to join them, you can use you can type J and just press enter, or otherwise you can also use another command which is known as group. Grouping is also somewhat having all the properties that apply to same as some join command. So I'm going to use the extrude. So what's the biggest height of this one? 80. Okay. So I'm gonna have to trim all the portions which are not necessary in this case. So firstly, I will complete this L shaped portion, and after that I'll come to these two. Okay, so how to prepare this part? So firstly, I want to make a square here of 40 by 35. Sorry, not a square, it's a rectangle. 40 by 35. 35, 40 again, right. Why there is a gap? I think I might have done something wrong. Dimension that I've given here. Okay, I'm going to keep this one like this. Now here, how much angle how much dimension that I have to go down? Since this one is 40 and this one is 35, the total height is 80. 80 minus 35 means it is 45. So this height, this particular edge height is 45. That is there. I'm gonna press pull this one since I need a hole up to a dimension of 35. Okay, now see here, I will go to the shaded mode. Okay, here how do I actually make this slot? That's the question. How to make it? See, I'll show you something. Suppose if I make, so depending upon the given dimension, suppose if I make something like this, okay, suppose if I want to press pull this one out in order to cut this one out, what's happening here? Can you guys see that? That's an inclined slot. But here, what I actually require, the slot that I require is a vertical one. This is a vertical slot. Okay, this one is a vertical slot, but whereas here, if I am trying to press pull this one, I am getting an inclined slot. So to create this slot here, we will going to use the bottom view. Somebody change the axis here. Okay, I understand. That's the coordinate system that we require. Okay, whatever it is. So here, let me delete this line. So with the given dimensions, at this bottom one, on this bottom one, I am going to create the slots like this. See here, I'm gonna, since this dimension is 40, since the total dimension is of 70 minus 40 means this particular dimension is 30 mm, right? So here it is going to be, this slot should have a dimension of 30, but whereas see here, we were actually specified with 25 mm of dimension, which means I have to leave 5 mm of dimension. So I have to create a slot which should be having a lateral depth of 25 up to a height of 80. And here, if you consider one more thing here, this slot width is not given directly, but see here, this dimension is 35, which means this particular edge has a dimension of 35, which means this edge is also 35, right? This dimension here given as 10, which means if I subtract 10 and 10 from this 35, which means 20, I will left with 15 mm of dimension. So now I got all the dimensions that I require. This dimension is 15 and the total height is 80 and this particular dimension is 25. I'm gonna go from this way, 10, after that 25, 15, 25, I'm gonna take the press pull up to 80 dimension. I have created the slot that I require, but see here, if you guys observe, I'm gonna turn the X-ray mode on. Actually I require a small portion of this thickness here, but whereas I've lost it too while making the slot. How do I get it back? Again, for this one I will go to the press pull. See, this one is a small region, so that I can select this one. The height that was given is 5 So press 5, go to shaded with edges mode. There it is. Okay, that is how you have to create this one. So now what I'm gonna do is I'm gonna take this dimension to up to the 20 mm of dimension, so which means 60, which means I have removed the portion that I've created. Now I need to create this additional geometry. By the way, the arrow is not actually given. I will take the arrow in the way that I actually want to, and after that I'll draw the front view, top view and side views of this one. So here, in order to create this extruded triangular face, I was given these dimensions 30 by 40, and here the height has to be 15. See here, this height, this particular height is 20, which means if the total edge dimension is 40, if this dimension is 20 means this height is 20, right? 20 plus 15 is 35, right? Now this dimension is 30 and this dimension is 40, so we can create the solid. Three zero 40 okay. I'm gonna extrude this one up to a height of 20 plus 15, 35. I know it is confusing, all you guys need to do is practice. Okay, 35, and after that this one here. So how to take these edges here? So that is one of the questions. Suppose this particular edge and this particular edge both are parallel, right? First I'm gonna locate this point. After that I'm gonna create the geometry. "35, 40", which means that's the location of this point. So I'm gonna create the geometry, but before that I have to take an extra dimension of 15 here. So I'm gonna draw a line up to this dimension. It is 55. 55 plus 15 means 70. Okay, so after that I have to okay, now I can extrude this portion, right? No, press pull. No, it is not taking, so that's the reason why I have to join them first. Yeah, line, but this one got after this one, so I'm gonna use the join command. I'm gonna try to extrude this one. Okay, this one line has got extended, that's the reason why. Okay, now it can be extruded. I'm going to click on the move tool about this one as the base point. Wait, let me rotate. This one is getting complicated. Okay, now what? I'm gonna snap this point to this location. Okay, everything exists. Okay, I wanted this thing to be. Now I'm gonna extrude this one to the height should be 40. I'm gonna move this one downwards. Okay, no need to. I don't have to delete any edges. So that's the geometry we needed. Okay. So which view that I have to take right now? I'm going to consider the arrow direction. In this way. Okay, I'm going to consider the arrow direction in this way, which means this is the view that I need to take in order to get the elevation or the front view. Excuse me. Now, so if I go to the 2D, since it is a forced angle projection, at the time I was studying, I've learned both of these first angle projection and the third angle projection as well. Just want to show you the let's worry about this one now. Front view. So since this one is not a perfect orthogonal view, okay, this is the perfect orthogonal view. So whatever the edges that I can see, I will mark them with the thick lines, of course, obviously, and whatever the edges that I can't see, I'm gonna mark them with dotted lines. The height is, first of all, this dimension is 120 plus 15, 135, and the height here is 80, 35, and what else you see? You will see this particular face, and this particular face has a dimension of 35. $35, 10, 30, 15. Wait. Ah, yeah, that's it. And again. This one should have a height of the entire line. I've left 5 amount of portion here. 5 mm from the top view. I'll get from the side view also. From the side view also 5. We will keep this edge right like this. Okay, this one is one of the complicated ones. It should have a height of 20. 5 plus 15, correct. And after that we have to left 15 mm of dimension here. I can delete this one. So this small portion can't be trimmed, so height should be 40. Wait, I think I hit 40. That's 40. And after that from the front it will all look like a single edge, and after 35 mm dimension I have to take another edge here. Okay, see here, this edge and this edge seems to be a single edge. We don't know the perfect dimension yet, but this dimension here is 30, this one is 35, and 35 from this edge there is a vertical line. You have to measure the angle. See, depending on the angle here we have to measure this particular dimension. Okay, so I'm not going to measure the angle since it is going to take certain time. This is one, and I'm going to extend this one to up to this location. It will come somewhere near to this one, and after that this particular edge. Good afternoon. And this particular one's height is 15 plus 20, 15 plus 20, 35, 35 is the height. 35, 15 is fine. Now where is this? Yeah, about this height at a distance of 30. Zero. That's it. That's how it looks from the front. But whereas this edge here, okay, this particular edge will go down up to certain dimension, but we won't be able to see that dimension, so I'm gonna mark this one with a dotted line. Up to this one, I'm gonna have to create a layer, new layer. I'm going to decrease the relative scaling to 0.1 so that you guys can actually see this one is a hidden one. Now so from the side view So what are the things that you see from the side view? What faces do you actually see? So you will see this entire 70. So from the side view, its height is going to be 40 and this dimension is going to be 70. It has a dimension of 20, and if you want to measure the angle as well, depending upon the angle only this dimension can be found. Okay, and by the way, this dimension is 40, so which means from the total 70 dimension, if you subtract 40 means you will left with 30, or otherwise you can just take these projection lines 40, 30. Since that one is 20, it is 15, it is going to be 25, so 15. This one should also be 20. And if you guys remember, I left one more edge here, okay, which actually comes here, and there are two more edges which has to come here, but I haven't drawn them. Just wait, because without the side view projections it will be complicated to draw them. Okay, I cannot add this one until the end. Now this is 1, this is 2. This one will, this edge will exist at a dimension of 40. So from the end take a height of 15 and up to a dimension of 40. Okay, and after that rest is up to us. Okay, we have to mark 70 mm of dimension from this edge, 70, and then up to height of 35. I know it is confusing, don't worry. So at this particular location 40 and this 35 has to get combined. All it does require is some imagination power. Once this one is got completed, I will tell you guys how to model a bicycle in the 3D view. Okay, wait for that if you're interested. This one, this is 2. Yeah, at a dimension of 5. 5. I draw a vertical line. Okay, at this particular location this edge is going to stay. That's the dimension that I was worrying about. Okay, I'm gonna give these two also a green color. Up to 72.5. I'm gonna need this one to be 72, so which means it will comes around 67, 67.5. That's it. So this line here is going to be a dotted line, and this line here is also going to be a dotted line. That is how it looks, right? So that's the figure that we actually needed. Okay, and we have to connect this 20 height edge here. And this particular edge here has to be extended until the end. Okay, I don't see this line. Okay, so that is what that is how it will look from the side. Okay, I'm going to take this to you guys to the side. Okay, by the way, these are dotted lines, which are the hidden lines inside of the component geometry. So that's the view. I hope it is clear to you guys. And after that I'm gonna have to draw the top view as well. From the top view, you will see this rectangular face, triangular face, and this rhombus face, and all of them. So first draw the 70 by 25, 70, 135, and 70. Oops, I think I might have done something wrong. 70. Actually we need to take this angle, but I'm going to leave this one like this. From the edge I'm going to connect it to this particular location, so depending upon this location. So this, since this dimension is 40 and 35, I'm going to take that 40 and 35, right? 35. So that's the location. Right, this one is 40. Okay, this one is 40 and this one is 35. So this particular edge has to come here. I have to extend this one. Up to, this means I'm drawing this line. Okay, up to 40 it should be extended. This one is 40 from this side. Okay, I have considered this one from this side. Right. Right, like that. Up to this dimension. Let me draw another line so that okay, that's the location that I require. I'm gonna erase this one and yeah. Right. 30, 40, take the 30, 40 here. Let me take the 30, 40 here. Four, 0. And 3, 0. And these one is not the one, should be extended up to this location, and I have to trim this edge want to be there, and similarly okay, from the top it will extend till the end. It will reach up to a depth of 25 and this one is 15. And is there anything else that we require? No. So that is how it will look from the top. I'm gonna give this one a blue color. Okay, so that's the front view, side view and the top view. I'm going to show the top view as well. This one stopped working. Okay. Oh wait, this line won't be there. That's it. Okay, I know it is complicated. I've taken the complicated problem. Now I will try to show you guys how to model a bicycle in the AutoCAD. Not much of time left, but I'm gonna try my level best to complete it within time. But otherwise I'll give you guys an outline. Okay, how about that? Why don't you guys try it at your homes? Then I'll give you the hint and how to do that, how to prepare this bicycle in the AutoCAD. This one is just to show you guys what AutoCAD is actually capable of. AutoCAD is actually capable of more than what I know. So here I will take a small line. I'm going to take a dimension, say 0.5. That's it. Now I'm gonna create the arc using the center, start, end and the radius. Okay, I have to take it from this direction. Yeah, I think that dimension will be enough. Okay, so what I'm gonna do is I'm gonna first create the tires, but before that let me join this geometry. Now I need the circle. Can you guys see the circle that I'm creating actually is in the XY plane? I can't draw in the YZ or ZX plane, but I can change the coordinate system here. I'm going to move this one. Specify the Z vector direction. Now I'm going to create the circle. Yeah, I have to create a horizontal line. Why? Z position is already that way. 6.3. Okay, whatever it is, just to show you guys roughly. That's it. I'll try to move this one. Now I will go to the solid command, solid 3D modeling command. I'm gonna sweep this curve, sweep this. I need this thing to be curved, so it will comes around. Fillet has to be very much looking. Let's try this one. Now I'm gonna take the fillet, radius 1, it is too much, so I'm gonna reduce the radius to 0.5. Yeah, that's fine. But before I do anything, I just need to join them all, otherwise group them all. I'm gonna join them. Not much of a time left. I'm going to try to finish it off as quickly as possible. I'm going to take the same rectangular shape. I'm going to use the same loft command, the sweep command again. I'm going to have to join them as well, because you can see a lot of geometry is interacting here. Sweep that about this particular path. So what I can do from here is I'm gonna create a circle. Just not taking anything. So let us just directly create a circle first of 0.3. Then I'm gonna extrude this one. For that much of height. I'm gonna 3D move this one about the base point to. I'm gonna turn the orthogonal mode off. I just wanted this thing to sit on top of this. I'm not able to use the 3D snap. Okay, now you can just add some of the structure that you need to. I'll show you guys how to extrude these portions. Oh my god. Okay, I've turned the orthogonal mode off, so that's the reason why they're behaving this way. That's why orthogonal mode is very much important. It is going to make sure that everything is actually is in position or not. Stop it here. That's it. I'm going to snap this one here. Oh wait, I think it has messed up a little. The y-axis is not working properly here. Though I have defined a proper system. So what I'm going to do now is I'm going to create the UCS again to the end point here. Why don't we just try it here? Okay, I think it will work fine now. Now what I'm going to do is I'm going to just suppose if you want to extrude along this particular line, click on this z-axis vector and select the two different endpoints of the line, and now create a circle. I'm gonna give this a dimension 0.3 and click on extrude. Click here. I'm gonna have to select this one first, and then I'm gonna extrude this one. Click on path here and give this path. Likewise, if you extrude this one, you can extrude along all these different lines, and you can also actually create a small seat here also. Okay, if you became good at modeling. The reason that I'm showing to you these items is what? Okay, I hope I'm audible to you guys. The reason that I'm actually showing to you these things is because modeling in AutoCAD is very much easier. So whatever the geometry that you want to create in AutoCAD is very much easier than you actually think. Okay, all you need to know is what tool have to be used in what time. Okay, so remember these points. Since there is not much of a time left, I'm not going to complete this geometry here. Okay, suppose if you want to extrude certain shape along this line, which means the circular one, obviously select like this, click at this joint, give a circle of radius 0.3. in my case it is 0.3. okay, you can choose whatever the radius that you want to. I'm going to give this one a path along this one. Okay, you can do so many things more than just a cycle in this AutoCAD. I hope you guys have learned something today. I'll see you guys in the next class. The time is almost over. It's over, 6:30, and don't forget to give the feedback as well. Okay, if you have any doubts, you can post them in the comment section, or You can also post them in the Google Classroom as well. I hope it is clear to all of you guys. Okay, I'll see you guys in the next class. And don't forget to give the feedback. Submit the feedback while you're leaving, before leaving.